All right, this unit is really cool. Now we're going to do something called implicit differentiation. I love implicit differentiation. I got so excited I had to put my fancy headband back on. I'm going to be honest, my students hate implicit differentiation. And I'm not really sure why. So when you get to class, maybe you can tell me you loved it, you hated it. Why? To me, it's a really slick trick. And to me, most of mathematics is just a trick. It's just some sort of cool way of figuring things out. Um, but implicit differentiation is a way of solving what we're going to call differential equations when they're really kind of ugly. Now, I'm going to start this by actually just doing one for you. Suppose I have this function right here. I mean, I could divide through by 2 and find the derivative. But let's pretend like it's a little bit uglier than it is. Suppose I were to just take the derivative with respect to x of both sides. And this one's not very hard. As a matter of fact, you can do this one pretty easily without implicit differentiation. All right, the derivative with respect to x of 2y is just, I'm going to pull that constant out. Now the derivative of y with respect to x, I'm just going to call that y prime. A lot of times this will be a function of y. And this side, the derivative with respect to x of x squared is 2x. The derivative with respect to x of 2x is 2. And the derivative of a constant is 0. So I have just taken the derivative with respect to x to the entire equation. And now I'm going to gather all my y primes. I only have one y prime. It's kind of a boring problem. I don't like this one so much. All right, I only have one y prime. And I'm going to isolate that y prime by dividing both sides by 2. So y prime is 2x plus 2 divided by 2. I know I'm being picky on the steps here. So this is just x plus 1. All right. That's not so hard, but it could be much worse. These are the guidelines for implicit differentiation. You differentiate both sides with respect to x. So let me do this. What if I had this function right here? Is 2x plus 16. I know, they're even. I could divide through by 2, but I'm not going to. Differentiate both sides with respect to x. Collect all terms involving dy dx. On the left side, move everything else to the right, and then factor out dy dx and solve for dy dx. So what do I do if I have this right here? All right, I'm going to apply d dx to the entire equation. So this is d dx of 2y squared and d dx of 2x plus 16. Let's see. So this is 2. Let's see. Derivative of y squared with respect to x is y. I reduce a power times y prime. And this is 2x plus 0. I'm going to divide through by 2. So y prime is equal to x divided by y. That's it. You're done. You don't have to go back in and solve for y or anything. As a matter of fact, a lot of times you can't. You wind up with these x, y terms in there. It's kind of a mess. All right, let's do this one right here. This one has a y squared and a y term on the other side. So I'm going to take the derivative, and this is what I tend to do. I just tend to do this, and I do it to the entire equation. So I'm reminding myself I have to do the entire equation. I can't just pick the half I wanted to pick. So this is d dx of y squared and d dx of x cubed plus 2xy plus x. All right, so this side, this is 2y, y prime, and this is 3x squared. Now I've got to use a product rule, plus 2y plus 2x y prime. I want to show you this term right here, when I do the derivative, gives me these two terms. And then derivative of x with respect to x is just 1. So let me kind of show you where these terms came from. Do I have another color? Yeah, here we go. All right. Now I want to collect all my y prime terms. There's a y prime term, and there's a y prime term. Okay, I'm 105 years old. I've been doing this since Columbus sailed across the ocean blue, and I underlined them. So there is no shame in underlining and using yourself, just using some tricks here. All right, so this is, I'm going to factor y prime out, or let me do it this way. 2y y prime minus 2x y prime is 3x squared plus 2y plus 1. Now let me see, are all my y primes on one side? Yes, I'm going to factor it out. So y prime, 2y minus 2x, is that correct? Yes, is equal to 3x squared plus 2y plus 1. So now I'm going to solve for y prime. Y prime is 3x squared plus 2y plus 1 divided by 2y minus 2x, and this is true for all x and y that are not equal. Now, you don't have to solve for y. You don't have to plug it back in. That's the beauty of implicit differentiation. It takes something god-awful and ugly and gives you something god-awful and ugly, but it's very straightforward. All right, so remember, apply the derivative. I'm going to back up here. Apply the derivative with respect to x to both sides. Collect your xy terms. Factor out dx dy, and solve for dx dy. Your turn. Turn off the video. See if you can do these four. When you're done, turn the video back on because we're not quite done yet. All right, why do we do this? Because sometimes we are able to do something called a slope field. Now we're going to do an entire unit on slope fields, so don't panic too much about this. I just want you to get the flavor of them for right now. You remember dy dx is a slope at any point. Let's see. So for all x equal to 0, according to this, dy dx is 1. So for all x equal to 0, oh, it would help if I could actually draw my little arrows here. Oops, didn't mean to do that. Let's start over. This is what happens when you get carried away with technology. All right. All right, what this tells me is all along this line right here, where y equals x, I can put a little dash, and this little line has a slope of 1. Now, let's come over here. What happens at x equals 1? Then dy dx is equal to 2. So at x equals 1 here, we're going to have my slope is going to be 2. Now these don't happen to depend upon x. You're going to do one where it does. You got the idea? At x equals 3. Then the slope is 4. Okay, so we're going to come over here, and this one's going to be really steep. All right, and you're just putting really short little tick marks. You're just getting a flavor for what the slope looks like. Now, can you figure out what, when x is equal to 2, it looks like? Of course, the slope, dy dx, is equal to 3. And so this one will be somewhere between these two, which heaven help us, I'm not very good at this. All right. This is called a slope field. Let's go backwards. What about when x is -1. I don't know if you're going to be able to see these. Then the slope is 0. So I can do 0 pretty easily. There we go. It's just short little horizontal lines. All right. When x is -2, dy dx is -1. So it's going to go down like this. You kind of have the idea? Let's see. What about when the slope is, or when x is -3, then the slope, I'm just tired of writing that, is equal to -2. So this one's going to come down quite a bit more. All right. So you see, if you back up, you can almost see a curve in here. These are slope fields, and I want you to practice one or two of them. That's not one of them. Stop the video and see if you can do this one on your own. When you're done, come back. Another reason we use implicit differentiation is to find the derivatives at points. So let me use implicit differentiation here. I'm going to do d dx of y squared is d dx of x squared minus 4 divided by x squared plus 4. Oh, this is ugly. So this is 2y prime is equal to, oh, let's see. We can use, I got to tell you the truth, I prefer to use the power rule. So this is x squared minus 4 times -1 x squared plus 4 squared times 2x plus x squared plus 4 to the -1 times the derivative of the numerator, which is just 2x. All right, so what do we have here? I'm going to go and take a 2 out of everything because I'm going to get myself in trouble if I don't. So y prime is, what is this? Did I do that right? Minus x squared minus 4 times x squared plus 4 squared plus 1 over x squared plus 4, oops, times x. Now we want to see the slope at 2, 0. So everywhere I have an x, I plug in 2. Everywhere I have a y, I plug in 0. So this is -4 minus 4. Well, that solved that. Times 4 plus 4 squared plus x is 2 divided by 4 plus 4. Now see that goes away, so that makes me happy. 2 over 8, or 1/4. So I know the slope is 1/4. Now I could also find the equation of the line through that point, because once I have the slope and have the point, I know y minus y1 is equal to the slope times x minus x1, where this is x1, y1. So the equation of this line is y minus 0 is equal to 1/4 times x minus 2, or 1/4 x minus 1/2. All right, your turn. See if you can find the equation of this line at that point. And when you're done, turn off the video and finish your homework. Hope you enjoy them as much as I have.